Yeah, in this video, I'm going to talk about the speed of light. Einstein says light is constant. Light is constant. It doesn't change. The kicker is that he has related the speed of light to the universe, to matter, planetary matter, any matter, all matter, or all mass, if it is in fact some type of energy, which everything points to, gravity. But could it be a magnetic interaction between? See, energy is one thing, but magnetic energy, let's say, is another. Magnetic energy tells us that certain magnets of the element would stay together. So we have matter, we have things, we have birds, we have people, we have animals, we have rocks, we have all this stuff that we're talking about. And it's called stuff, actually. And is that really, is it mass, or is it a magnetic field of some sort? Now we take the Earth's core, is that magnetic or is it energy? And we take a moving object, and the comparison between the two, is that energy or is that magnetism working? Or is it one or the other, or both? He also compared the light constant, which is light, to velocity, energy relative to propulsion values, the speed of light. He put the speed of light in everything. Now, that's making the speed of light confusing. What are we talking about? Velocity? We're talking about energy. Is it a type of energy? Sure. But we still don't know what it is. For some reason, when we get into the molecular structure of things, everything starts to become negative, not positive. And so what holds all this together? Is it positive, negative, or is it mass, which is all positive? Reluctantly, I think that's what Einstein was talking about, that it's all positive energy, which also includes the idea, whatever it is, it repels. In other words, you take two pieces per people and put them close together. They don't intertwine. They don't, at the molecular structure, doesn't one enter the other. They're separate entities. When you put on glasses, like me, those are separate entities, and it's temporal. It's I can take them off and I can take them on. I can walk to and I can walk away. So what are we talking about when we talk about light constant and that energy? It mass is energy. What type of energy? The molecular energy have to do with, so he goes into the idea that, well, light is proton particles, so that's energy, but it's not proton particles that hold matter together. This interaction, what is this interaction? There is an idea that gravity might be something that is put in motion at the universal level, and it includes everything and everybody. In space, we have zero energy, so what is gravity? Gravity is the accumulation of all the, let's say, go to the galactic scale, and it's all the galaxies. Now, all these galaxies seem to cling together at some point. And there's something expanding our universe. Hubble describes this as like a balloon, inflationary balloon. It's just getting bigger and bigger. What is that interaction? Where does that energy come that affects space? At the center. The energy from the galaxies are all over, like they're all over this round thing. There's billions and billions and billions of galaxies, and those are the biggest things that we know that exist. And there's something at the center, midfield, that is inflating, getting bigger and bigger, pushing the galaxies apart more and more. And it's this action, this interaction between this expansion and the galaxies that puts everything in motion at a constant rate. So what is this motion? Now this motion is uniform. It's also similar. It's and inside the galaxies, which in effect are planets and stars and solar systems and suns and all these things that we see from Earth when we look out. But they're so far away, all we see is a reflection of the light that it interacts with the darkness at that level. It's matter interferes with the light, causing it to, whatever is in front of it, be seeable, lights up. So we look in the sky and we see a bunch of white lights inside our galaxy. We go outside the galaxy, we have what's called interstellar space, which is the distance between galaxies, which is enormous relative to their energies. Their, could it be magnetism? Mass, energy? I don't think we really know yet. It's like black holes. The only black hole we have ever encountered is at the center of our Milky Way, but scientists believe that it exists in all the galaxies. And I wrote a book on that. It's Popcorn Universe. It illustrates an evolution of our galaxies in our universe. So my theory is that expanse puts everything in motion. Now, on Earth, inside the atmosphere, the effect of the gravity, that which is outside of our Earth planet, we rotate. This is uniformity. It rotates at a certain speed and doesn't change. And the other 8, 9 planets rotate around the sun. It doesn't change. They each have their own velocity relative to their mass size, how big they are and how much energy they put out. So we have a division. Now, on Earth, we have what is known to be gravity. the interaction of what is gravity? Actually, mass, interaction of mass. Is it, again, magnetism? Magnetism is a great force to explain how things can stay together. It's also a good explanation why they don't fall apart, because at the molecular level is so small and dense that everything clings together like a glue. Now, gravity on Earth is measured by, let's say, throwing a ball up, it comes down. Is that magnetism or is that energy? And it falls at a certain rate. All of it is the same, no matter what. The only thing that interferes with the movement of gravity is the air, wind, and things that have a push force that interfere with the fall of gravity. And all matter is the same. No matter, you got a marble and you have a bowling ball and you drop them and they both fall at the same rate. This has been proven, and that's what it is. So if it's energy, you would think that the bigger one have more energy, would fall the same. So mass is put out of sequence. It's all the same. Einstein said matter, energy, energy into mass. Mass is the energy. Mass must not be magnetic, maybe. That it's a type of energy which we don't know, except that, like human beings have an aura, or something that we feel things around us. Sometimes we don't have to look behind us to know there's somebody standing there looking at us. This is an interaction of our aura. Matter has an aura, which makes things around it predictable. But where does this aura come from? The energy? So you have a bunch of it. What is mass? What is energy? This is what we don't know. So scientists don't know. Physicists actually don't know what this is in actuality. Einstein tried to correlate it with electricity. Electricity has an electrical aura. The force of electricity is not in the wire, but around the wire, and it's invisible, and that's the way it's carried outside the wire, not through the wire. But when you interfere with that wire, then that's called ground, and it grounds, and you get an action. Run electricity to a line and put your finger on it, you probably get shocked, get a burn. So, what is mass? A type of zero-point energy. Energy that exists at the molecular level, which is negative, which means that it doesn't gain mass, it has no mass. And the mass that it does have is, no matter what the size is, it's all the same. So they follow the same rate as a force. So what is gravity and what is mass? Mass is negative until grounded, become positive, and if it's in the air, in motion, it's 0 point energy. That's why they both fall at the same rate. So it's that force outside the wire, or the force out that we can predict outside the mass, that the marble and the bowling ball both fall at the same rate to our Earth from higher up. When we talk about space gravity, we're talking about momentum, the action of whatever it is at the center of our universe that all the galaxies cling towards but don't interact with, create a force, the same way that the moon affects our oceans. What's the biggest element can be formulated in space? Cold. It's cold in space. Where's the heat come? From the suns. And the suns are part of systems inside the galaxies. So we have all these galaxies clinging to something in the center that is causing it to raise its current. Like the ocean, we have high tide, and then when the moon's farthest away, we have low tide. But in space, all the galaxies, what kind of interaction would that create if they never change? It's constant. And since it's constant and it isn't variable, there's no high, low, and low, that it stays high and it increases. And that's what our universe is. An interaction with matter and space, the elements, creating an anomaly, some type of sphere, because all the galaxies are around this round thing, and it's inflating. Now Einstein would say in his theory, well, space is flat and it's rising. And since it's rising, that's inflation. And because we're getting more space, makes the galaxies separate. And what keeps the galaxies together? The interaction of all the matter that falls independent to that galaxy, whatever that galaxy is. So in this video, I'm trying to give you an explanation of what I call the expanse vacuum gravity. A form of gravity is a force outside what we actually know about energy. And how it works, like I said, electricity, it's a force. It doesn't flow through the wire. It formulates outside the wire the same way we do, and all matter does, has an aura, some type of an aura. The glue that keeps us together doesn't intertwine with whatever it touches. It doesn't stick to it. Become a whole or part, that would be called collapse. Or Yeah, collapse. So when we look up at the night sky and we wonder why everything is put in motion, it's all the galaxies in a dance formulating something in the center that is causing it to increase in mass and energy, or a force. See, the energy that flows through the wire sits outside the wire, which acts as a force. It's not in the wire. So if all the galaxies were cease to exist, so would the anomaly in the center. So what do we talk about? A force. We're talking about a force. My name is Rod Kowicki. Thank you very much. My book's on Amazon if you're interested. I got several books. Popcorn Universe tells you about how the universes were formed and developed, and the speed of light, and space travel, etc. Thank you.